Hi, my name is Isabella. It's a pleasure to be here all the way from New Zealand. This project was towards my Masters of Design Innovation at Victoria University of Wellington under Industrial Design lecturer Tim Miller. It's entitled Design Deposition, and it's about freeform 3D printing for digitally crafted artifacts. So just quickly, what exactly is freeform 3D printing? Essentially, it's the same technology as standard FDM fused deposition modeling printing using an extruder and a CNC technology. The difference here is that instead of building in layers and having support material, now we're having material that solidifies upon extrusion and can support itself. So we no longer need to build with support material, so we have all this new opportunity to build more three-dimensional more forms without having to rely on layers. So this project essentially was about how we can use this new use of an existing technology and create new qualities through that. So by cutting out generic slices, we're no longer building from solid form and using a generic slicer to print it into layers. We're instead cutting and designing straight through the toolpath itself, so we can have complete control over every strand that's printed, essentially. So we can have more diversity of results and use these diversity of results towards the printed product. We went through and how do we look at exactly what other freeform projects were doing, and kind of so that we could build information from them, creating a infographic just so we could understand exactly what materials they were using, what extrusions, what CNC devices they were using to build it from those. So it was found that a lot of the really successful, beautiful products that would come out of it were in the architectural realm. So looking at kind of big structures using kind of the space frame approach. This is actually from a student at Victoria University as well, who's an architecture student, but and it's quite common in other freeform precedents that they'd build in this kind of bands of layers, so still kind of like traditional 3D printing, building from ground up. The difference that I wanted to create was, instead of slicing through form, is having the material respond over and with the form. So the toolpath and the form were designed concurrently. They were built together rather than creating a solid and cutting it to create form. And this was from an industrial design perspective, so how we can use this new control over the material to enhance the function, the value, and the aesthetics of its printed outcome. And we're also using kind of traditional 3D printers, standard FDM printers, quite lo-fi technology, really accessible, instead of the large 6-axis robotic arms that was commonly used. And yeah. So hardware-wise, there wasn't much adaptation needed. It was all there. We created new nozzles just to get a bit more, so we could get into smaller nooks and crannies. But essentially, all of the control was really just in gaining control over the software side of things. So using Grasshopper, a plugin for Rhino, to create the G-code that was needed to print the products. So essentially what would be input would just be the curve, the toolpath that the printer was going to follow. So that was essentially the toolpath was the printed product, was the deposition itself. And this allowed for diversity of results both within prints and over separate prints. And as well as that, the Grasshopper was also used for user customization of products. So completely unstandard and having just lots more diversity in the qualities that we can achieve. The material used was just standard ABS as well, and it was more about the deposition itself rather than the material. Because we were no longer using standardized slices, we had to go through quite an intense settings phase to kind of work out what the best temperatures, what the best settings were. So temperatures, and these were the settings, and looking at what the best print qualities were for different results. And same with printing spatially, so making sure that it's self-supporting and solidifying as much as it needs to. And we could feed back those results into the Grasshopper script to get those numbers and relationships. And put that back into the script to be printable. We also found out there are different settings for going up to going down to compensate for kind of gravitational pull, and then just checking that these settings worked. But what it was really about is how this kind of got applied to products and qualities. So there was sets of abstract experiments just to kind of see what opportunities, what textures we can create. And there was 3 series there The first was about minimal base adherence, so now that we're not relying on support material and building with structure underneath, so we wanted to make sure that we didn't just rely on a flat plane, we could still create these really beautiful three-dimensionality through this process. So this was looking at creating 3D underlying forms. The second series was about dynamic layering, so while no one longer wanted to rely on building in layers to build form, still kind of using layers to create structure and then integrating spatial features as well. And then the third series was about structures, patterns, and tectonics, so looking at how and where structure was placed and how that would impact the kind of integrity of the print itself. So where there's crisscross, it becomes quite strong. Where there's spirals, you kind of get this spring-like effect, and then like the one on the end, it would bend in one direction and not the other, and so how we can use that towards products. So now that we had this kind of inventory of qualities that we can use, we wanted to apply those to some products. So there were kind of 3 series that we did. The first one was looking at, solidity and open structure, and how now that we're controlling to this single print strand, we have so much more control over going from dense to open forms. And this was applied to a kitchen utensil set. So measuring spoon had the requirement of still being watertight, where the whisk needed to be light and open, but still strong, and then the sieve going from a dense handle to an open mesh. And these were the final toolpaths of those prints. They all nested in together, so you can see the really different qualities of the light and the dense coming together. Some close-ups on the sieve, so again using that responsive method of form, so the build lines go over and around form rather than cutting through, and being able to create these light open meshes with each single strand. And this is the measuring spoon, so watertight, and then also using texture as indicators of measurements. And then the whisk there as well, and using multiple strands to create thicker areas. And just being able to get new qualities for the print rather than the classic stair-stepping qualities that you would get from just using traditional slices with FDM printing. The second application was kind of mechanical use, and this is applied to a mouse, how we can create kind of connections and details. So there was a mouse top and a mouse base created. And those are the final toolpaths. In this one, there was also brought in some ergonomic inputs, so we could take different dimensions from the hands, and this would affect not only the form, but the print structures as well. So this is the final printed mouth. The top piece could kind of be squeezed and then released into the base, crisscross over the back to create structure, and then where the form flows parallel, you get flexibility over where the buttons are and things like that, and also used to house the electronics. And the third application was to furniture. So patterning became such a big part of building form now that we weren't relying on standard slices, and how we're bringing parametrics into that as well could expand the opportunities. So there were 3 series within that. There was the chair top, which looked at kind of rotational patterns, a couch top, which looked at flowing over the form and creating this knitted-like structure, and then the legs that were applied to both, building upwards. The final toolpaths. And then with these, you could have really simple interactions that would impact to have multiple outputs really simply. Chair and the legs. And just a quick video of those in action. So really quickly being able to iterate and create diverse results. That's the final print of the the chair. So having structure around the edges and coming to an open back, different textures on the legs, and then same with the chair, couch, and really different kind of patterning systems. Just some more detailing of those. We also went back and compared, this was the print of the sieve, comparing it to standard FDM printing. So the 2 on the sides are the same model, but printed on with standard slices, and you can see much less material is wasted, and the time was also drastically cut down. And same with the quality. We didn't have to remove support materials, so we weren't losing where we weren't wanted to. So essentially, this was all about gaining just an intimate control over the printer, so it can hack to create new qualities towards benefit of the printed product, understanding the manufacturing technologies and pushing these boundaries through innovation. So working directly with Toolpaths to find new techniques. I'd like to just finish with a video of that after this actually. This was just some of the failures. There's a lot of failures, but those always kind of new qualities to inform it. Cool.